In this lesson, we're going to graph linear inequality. We have been looking at linear equations. Each of the equations, of course, has had an equal sign. What we're going to look at today is a linear inequality. Basically, it will look much the same, except for that we'll have an inequality symbol replacing our equal sign. When we graph a linear inequality, we graph it in the exact same format that we graph a linear equation. We use our slope and our y-intercept to get the line on the graph. The difference comes when we actually draw the line. If the linear inequality has a greater than or a less than symbol, when we go to connect the points that we've created on our graph, we're going to connect those points with a dotted line instead of a solid line. If our inequality symbol has a greater than or equal to, or less than or equal to, it has the equal to piece in it, then we'll use a solid line, just as we did with our linear equations. So a slight difference between a linear equation and a linear inequality is sometimes I will have dotted lines. So let's take this problem as our example. It says y is less than x plus 5. So at the beginning, we're going to graph just like a linear equation. We're going to use our y-intercept as our starting point. So let's go to 5 on the y-axis, make our starting point. Then we're going to use our slope to draw the rest of the line. And in front of x, we can put a 1. So our slope would be 1 over 1. So we're going to rise 1, run 1, rise 1, run 1, and so forth. Now, when we go to draw the line, we're going to go back and we're going to look at that inequality symbol. Looks like when I wrote my fraction, I wrote over the inequality symbol, so let me go back and fix that. We look at our inequality symbol and we see that we have a less than sign. So when we draw our line will be dotted. Okay, that dotted line means that I have a less than or a greater than sign, not anything equal to. Now, I want you to notice that I drew my dotted line and I extended it all the way across the graph. There's a reason for that. We're going to get to that reason here in just a minute. Now, when you graph an inequality, we have to consider that there's a lot of solutions to an inequality. If I tell you, for example, that y is less than 2, y could be all sorts of numbers, right? Y could be 0, y could be negative 10, y could be negative 500, y could be negative 32, y could be negative 1/4. There's all these possible solutions. The same is true with a linear inequality when we put it on a graph. There's all kind of solutions to this linear inequality. What we want to do is we want to find out where those possible solutions are on a graph. So in order to do that, we're going to pick a point. I'm going to suggest to you that we pick 0, 0. And so on my graph, I'm going to put a little x here at 0, 0. And what I want to do is I want to test that ordered pair in my inequality, and I want to see if it is a solution. So here's how I'm going to test it. My inequality is y is less than x plus 5. I'm going to plug my ordered pair 0, 0 in for x and y in this inequality statement. So in place of y and in place of x, I'm going to fill in 0. Now let's solve that. It says 0 is less than 0 plus 5. So 0 is less than 5. Is that true? Is 0 less than 5? Yes, it is less than 5. That means 0, 0 is a solution. That ordered pair works in this inequality. So notice what it says here. If I get a yes answer, then I shade on that side of the graph. So remember 0, 0 where I put my little X marks the spot? I'm going to shade every single ordered pair on that half of the graph. What that symbolizes is every single ordered pair where I just shaded would work when I plugged it into that inequality. Take, for example, the ordered pair 8, 1. If I were to plug that into the inequality, it would make a true statement. So all my solutions are in the red shaded area. Let's look at another example. Again, let's begin by graphing the same way. Let's start with our y-intercept at 1. And then let's use our slope. Our slope is 2 over 1. So we're going to rise 2. We're going to run 1. We're going to rise 2. We're going to run 1. And we'll do that a couple of times till we have enough points to create a straight line. Now, before I draw my line, remember I want to go back and I want to look at that symbol. It's a greater than or equal to sign. So this time, we're going to draw ourselves a straight line. Now, we have to do the shading part. So let's pick a test point. Again, I would suggest 0, 0, simply because it's easy to plug in 2 zeros. It's very easy to do math with that. So let's take our inequality. Y is greater than or equal to 2x plus 1. And then we're simply going to eliminate the x and the y. We're going to erase those. And we're going to go back and plug in 0 where the x and the y just were. Now let's solve. 0 is greater than or equal to 2 times 0 is 0. Now let's continue solving. 0 is greater than or equal to 1. Is that true? Is 0 greater than or equal to 1? No, 0 is not greater than 1. So look what it says. If we plug a point in, we plugged in 0, 0. If we plug that in and we get a no answer, we go to the other side of the line and we shade. Right? Notice I went to the other side of the line. Here was where my test point. I got a no, so I went to the other side of the line. Now, I want you to see how well you understand what I've said. I want you to pause the video. I want you to graph this inequality, get your line graph, do the shading, and then I want you to unpause the video and check your work. Check your work and see how you did. Now, just briefly, let's look at 2 last examples. If y is greater than or equal to 2, let's think about that. If we just have a y, we're going to have what kind of line? Horizontal or vertical? Well, let's think about that. Let's go to the y-axis. We go to 2. Okay, which way are we going to draw our line? It's not going to be vertical, because if it was vertical, we would just simply be tracing the y-axis. We don't want to do that. That means it's got to be a horizontal line. So here's our line for y is greater than or equal to 2. Why did I make it solid? Because it had the or equal to part. Now, we could actually plug in 0 in place of y. We could say, is 0 greater than or equal to 2? We could say, well, no, of course. So where do we shade? Okay, we shade on the other side of the line. And so you say, well, where is the other side of the line? Okay, in this case, when we have just a plain horizontal line, we want to just use our common sense. It says y is greater than or equal to 2. Well, y is equal to 2 right here on this line. Where is y greater than 2? 3, 4, 5, etc. So we want to shade everything above the line. We don't really need that test point. It's not particularly effective. Let's consider if we have x is less than -6. Again, here we're going to go on our x-axis to -6. And we don't want to draw a horizontal line because that would just trace the axis. So we're going to draw a vertical line. Now think about, what did I just do that was incorrect? Hopefully you see x is less than -6. I should have made a dotted line. So let's go back and make that line dotted. Now, again, just like when we drew a horizontal line, plugging in 0, 0 is not really necessary. It's the same thing with a vertical line. It's not necessary. X is less than -6. Where are numbers that are less than -6? -7, -8, -9. So we would shade on this side of our line.